Hi, and welcome to this third lesson of the R course. In this lesson, I will talk about spatial object, how to import a spatial object, how to change its coordinate system, and how to plot it. In the main page of the R course, you can find the dataset that I will use for this lesson. I put the file in this folder lesson 3. So let's take a look at the file. There is a shapefile, which is a polyline and is the border of the area and I want to use a data frame with latitude, longitude, and the variable of interest, in this case is oxygen, in a form of a txt table, and an ASCII grid. In this case it's organic matter.asc. So now let's open R. For working with spatial object, there are three main packages that you need to install. So for install them, go to Packages, Install Packages, and select the CRAN mirror closest to your location. In my case is UK Bristol. So the three packages are, the first and most important is called SP package. So you can scroll down to the letter S and select the SP package. SP and click OK. The second package that you need to install is called rgdal. So install package, scroll down to the letter R and select rgdal. rgdal and click OK. Every package has its own function, and in order to take a look at all of the function in the package, you can go to the script that I put on the page, on the home page of the course, and take a look at the end of the script. There are the references with the link to every package page. The third package that I want you to install is called Map Tools. So just scroll down once again to the letter M and go Map Tools and click OK. And this is the last one. Okay, so now we have all our package that we need for this lesson. So now we can just go to load package and we can load R commander. To load the packages that we require for this lesson, you can go to Tools, Load Packages, and select the package map tool. Okay, and here it is, the line of code, and in the output windows you can see that it has loaded the package. So you can also go to Tools, Load Packages, and select the other two. So rgdal. Here you can see it has loaded the package. If you want, you can also load the package by typing the code, the line of code library, and within the round bracket put the name of the package, in my case is SP, and submit the line. Here you can see, yes, submitting the line, and the package is loaded. So now I want to show you another function to set your working directory. Your working directory basically is the directory in which you have all of your data that you need for this session. So in my case, my working directory is this one on the desktop. So I will just click to show the link. I will copy the link, and then I will use the function set working directory, and within within quotation mark I will paste the address. The important thing is in this case is that R doesn't work with the normal address. So in this case, this is the normal address of a folder in Windows, and as you can see here, the symbol that you use is a backslash. R doesn't use a backslash. You can either use a double backslash. So in this case, you can just double this slash and submit the line, and as you can see here, it has submitted. If you cut this backslash in and submit this line, as you can see here, it gives you an error because it cannot recognize this address. So you can either use two backslashes, or an alternative is to use a forward slash, a single forward slash. Submit the line, and you can see you don't have any error. Let's just clear this Windows. So now this is your working directory. So every file that you want to load, you can just put the name and he add this address. He knows that all the files that you want to use are in this folder. So for instance, if I want to load our data, that in my case is the table that I showed you before. So if I want to load this data, I can use the function read table, within quotation mark say data.txt, which is the name of the file. The separation of each column is a whitespace, so I just put whitespace, and then because the first line is composed by the title of each row, I set header true, meaning that the first line has to be considered as the header of the file. And here you see it reads the file with all the data. With 3 columns, the first is latitude, the second is longitude, and the third is the variable. Now I want to call this table data, so I just give a name to this object, in this case data, and here it creates an object data, which is this data frame that I loaded. So if I want to check if the data frame has been loaded correctly, I can just click str, which is a summary of your data, with the name of the data, and as you can see here, it said data frame, 2 under observation, and 3 variable. And here you can see the name of the 3 variable. Now, of course, here you can see that at the moment this object it's a simple data frame. So the R in this case cannot recognize that these 2 columns are coordinates. If I want to convert this object into a spatial object, I can use the function coordinates data equal, and use this symbol and say that the 2 columns are named latitude, lat, and lon. If I submit this line and I repeat the summary of my data, as you can see here, the the object now as the class spatial point data frame. So I can use the function plot within the SP package, which is spplot, and plot the data as a spatial object. And here is your area with the value of the variable of interest. So now you know how to transform a table into a spatial object. Now I'll show you how to set the coordinate system. The function to set the coordinate system is this one. Projection for string data equal. In my case, I want to use a spatial reference number. So I can use this string (2078). In this case, I want to use a spatial reference number, which in my case is 2078. We stand for the UTM coordinate system. You can find other reference number at the address spatial.org. In this case, I also put this line to show you how to comment your code. So for instance, this line of code is recognized by R, but this line, because it has this hash symbol, is considered a comment. So if I submit this line, it just takes this one and this one is ignored. Because of course if I put spatial here and I submit this line, it gives you an error because it doesn't recognize the object. But if I put an hash key, it recognizes that this is a comment, so it doesn't care about the line. So now, as you can see here, it said project for string NA because it doesn't have a coordinate system. But if I use the same function again, the summary function, I can see that here now UTM zone 33. So he has recognized the code that I gave it to him, and now the object has a coordinate system. Now, of course, I can also import other type of spatial object. For instance, I can import raster. One of the main type of raster is the ASCII grid, and to import an ASCII grid I can use the function read ASCII grid. So in my case, the ASCII grid that I want to import is this organic matter.asc, so I can just call org matter and use the function read.ascigrid and put the name of the file, which in this case I can just copy from the original file and paste it here. Okay, close the quotation mark, close the round bracket, and submit the line. See, no error, so it means that he has imported the ASCII grid. Now, because I gave to the first object a coordinate system, I have to give a coordinate system also to this object. If I don't give a coordinate system to every object that I import, the SP package just recognize them as unprojected. So I can use the same string as before, copy and paste it, and just change the name of the object in org.mat. Submit the line, and you can see I want to see how the object looks like. So mat, close the round bracket, submit the line. Here you can see. Spatial, in this case, it's a spatial grid data frame because, of course, this is a raster and this is a grid. It's not a series of points. If I want, I can plot the points and the raster together using the function spplot. I want to plot my object, comma. I want to use a scale, a color scale for this object. And then, because I don't want to plot just the raster, which is this one, but I want to plot the raster and the points. So I use the option sp layout list sp points my data and the symbol that I want to use for plotting. In my case, I want to use the plus. Close this round bracket for this list and the round bracket for the SP. I submit it, and as you can see here, this is my raster and these are the observation. I can also change the color that are used to render the image. So I can go to R Commander and type the option call regions and put the color scale terrain colors and just put like 50 colors. So if I submit the line, you can see here the color has changed, and now he has a different color scale, which I like a lot more than before. So now you know how to import the data, transform it into a spatial data frame, and how to import a raster that you can. So now I will show you also how to import a shapefile. To import a shapefile, you need the package rgdal, which we loaded before. So it's loaded, so you can import the file, the shapefile that I give you, which is border.shp. So I just call border. This is the name of the object, and the function used for import the shapefile is read ogr, and ogr needs to be capital. And then I just put the name of the shapefile with the extension and the name of the shapefile without the extension. I submit the line, and as you can see here, he has imported an Esri shapefile. So now I can give the coordinate system to this shapefile. Let's call border and submit. And of course I can also create a plot that put together all the three data that I have in my folder now. So I can just use, for instance, instead of the function spplot, I can use the function image to plot my grid, which is in this case is this one. If I submit, you can see that there is a grid. And then I can use the simple function plot, which is available also in the SP package and is very powerful to import my data. Just put the option add true in order to give R, say to R that this plot needs to be added to the previous one. So if you submit these two lines, you can see that you obtain the same result as before. But now I can also use the function plot to plot my border with the option add true, very important. So if I submit those three lines, you can see that there is this grid, your points, and the polyline of the shapefile. Of course, now this plot looks very bad because it doesn't have a color scale, doesn't have the border, etc. So I can tweak a little bit this plot. For instance, I can change the color scale. So I can change the color. Instead of heat map, I can use the terrain colors. Say 50. And here is the difference in the color scale. I can add a box to the plot just using the function box. Here is the box. And I can also use a legend. I can also add a legend to the plot. So for instance, if I want to legend locator 1, because I want to select the location of the legend interactively, legend for instance from 1 to 10, because I don't have the breaks in the color, so I use just 1 to 10. The fill is the terrain colors. The title of the legend is legend, of course, and the size of the title is 0.5. So now if you see the legend is here, but of course because the legend is too big to be plot within the box, it's plot just the first line. If you want to change this, you can either plot your legend maybe here, but of course it's not the best place because it's overlaid to your map. So you can, in this case, you can put the option to say that the legend must be horizontal instead of vertical. So I can just put the option horizontal true, and put it right here, and this is your legend. I can also, of course, insert a title to the plot with the function title, and within quotation mark the title that I want to put. So now if you submit these lines, you can see there is the title, and of course because you have the legend, it must be inserted out interactively, so you can just insert it, and this is your plot. There are also in the SP package other options that you can use. So for instance, if you want to insert a scale bar or the north arrow, you can use the function spatial polygons rescale. It's very important to type the function as you see in this example with the capital S, capital P, and capital R, because the language R is case sensitive. So spatial polygon rescale with these three capital letters is not the same as spatial polygon rescale with, for instance, a small s or a small p, etc. So it's very important that the function is just like this. So if I want to insert the scale bar, I will use the option layout, scale bar, offset, which is the position of the scale bar. In my case, I want to insert myself interactively, so I can use the function locator 1. The scale of the scale bar, in my case, I can use 100. The filling, I want to be white and black, so I just type black and white. And very important, the option plot grid false, and this is the function to plot the scale bar. If I want to plot also the north arrow, I just copy and paste this line, and instead of scale bar I can just type north arrow. The filling, I can take it out because I want it just black, and the scale state 40 should be smaller. If we submit this entire, I have to insert the legend with the first click, the scale bar with the second click, and the north arrow with the third click. If I want to insert some text here saying that this is 0 and this is 100 meter, I can do it with the function text. So I can just add text locator 1 0 and text locator 1 100 meter. Submit the entire thing. Legend, scale bar, north arrow 0 100. Of course now it's not in position, but you can do it better with some attempts. So this is the end of the lesson. In this lesson we learn how to import a spatial data object, how to create a plot with our spatial data and the raster. And now we can proceed to the next two lessons, which will be about geostatistical interpolation. So see you next lesson.